Yes, dear students, now I am going to tell you about transformer. This is very important device for the use as well as to be asked in every exam, practical exam as well as theory exam. In both exams or competitive exam, everywhere questions are there in this on this topic transformers, and because it is the last topic, so students as well as teacher get fed up of teaching and learning and leave this topic. But it is important. In every exam, every year there will be a question on transformer. So now, what is transformer? It is, you can read from the book also. I'm telling here. Transformer device which converts high current into low and low current into high voltage into low voltage, low into high, AC voltage, not DC. A transformer device which converts high voltage, low current into low voltage and high current, and vice versa, means low voltage, high current into high voltage, low current. Both the things are done here by transfer. Remember, it is used in AC, not DC. You will understand why. It consists of generally two coils which are insulated from each other and wound over a same soft iron core. Just for sake of understanding, I have taken the soft iron core. This is one copper coil, insulated wire. Actually, copper wires are insulated by putting coating of some insulating material like some oxides, and these are insulated so that they don't touch the core of iron. But to avoid there is term magnetic flux leakage, basically they are wound over the same core here. क्योंकि यहाँ we don't understand where the primary and secondary, so here you can understand primary coil and this secondary coil. This consists of two coils, primary and secondary, and here this is the circuit symbol. Just like for battery, you use this symbol. Circuit symbol battery key के लिए ये होता है. The same way it is circuit symbol for transformer. Remember it. These two coils, primary and secondary, this is core. These two lines represent core. These two lines here represent core. In Viva, people generally ask, write circuit symbol of transformer. So you can draw this, but there is a difference here. Sometimes this primary coil has more turns than secondary. Sometimes secondary coil has more turns than you can show. If I will tell you later on, there are two type transformer: step up, which increase the voltage, and decrease current; step down, which decrease voltage. So step transformer has more turn secondary coil. तो आपको दिखाना होता है तो secondary coil की ज़्यादा turn दिखा दो, प्राइमरी में 2-4 दिखा दो, तो it will be step up. The same transformer can be used as step down by changing the load resistance and supply. Here the AC supply. Here are a load resistance, means the resistance of devices which we are using. Like in our home, we use stabilizer. The stabilizer also consists of transformer. Sometimes that is used to step up, sometimes step down. When voltage of supply goes low, we use that step up and step down. And the resistance of devices which we use is called load resistance. Load means power output. Here load means not that weight. जैसे कहते हैं ना कि गाड़ी में ओवरवेट हो रहा है, ओवरलोडिंग हो रही है, तो वहाँ तो लोड मेजर बाय वेट इन किलोग्राम और क्विंटल. Here load is measured in terms of power input and power output. जो हम पावर कंज्यूम कर रहे हैं वो हमारा लोड कहलाता है यहाँ पर. I was confused when I was a student because generally initially we understand load in terms of weight. Here load in terms of power consumes. So you have got now. So simply construction. If you are asked in exam, draw explain transformer. Its work diagram and level diagram to बनाना पड़ेगा. It has two coils, primary secondary wound over same software and code. Now, what is working principle? Working principle. If you are simply asked a question of 1 mark only, what is working principle of transformer? Then you can write it works on the principle of mutual induction, which you have learnt. I have told you. If you are asked simply question of 1 mark, okay, what is the working principle of transformer? Then you can write its working is based on mutual induction. But if you are asked, okay, explain the working principle of transformer, then you have to explain the things which I am telling now. Working principle, है ना? The transformer works on the principle of mutual induction. Mutual induction. That is when an AC source is connected across the primary coil. I start writing here primary. वैसे कोई primary कोई secondary. Primary coil. Which coil called primary? Across which we connect AC source. Then an alternating current flows in the coil. This alternating current, now I hope I should clean it because it will take a lot of things. This alternating current which keep on changing in magnitude direction both produces varying, time varying magnetic field. Hence, periodically varying magnetic flux get linked with primary and secondary coils. Secondary coil is that which is connected across load resistance, है ना? So varying magnetic flux is induced in primary and secondary coil both. Remember that transformer work only in AC because of varying magnetic flux in primary and secondary induces here only. If there is no leakage, if there is no leakage of magnetic flux. That is same magnetic flux is linked. Same magnetic flux is linked in primary and secondary coil. Then this magnetic flux is varying magnetic flux and has induced EMF. Induced EMF in primary and secondary coils. Are given by EP equal to minus NP d phi over dt, phi magnetic flux, which is varying with time, it is not constant, and similarly ES minus NS d phi over dt. I have assumed here that there is no leakage of magnetic flux. But when we connect a source across primary coil, a varying current, alternate current flows, which induces magnetic field in primary coil, and that magnetic field produce magnetic flux, which will be varying with time. So here I can write ES upon EP equal to NS upon NP. Again, number of primary and secondary coil create different EMF in primary and secondary coil. Okay. Now, like cells, but the coils are made of copper wire. Every copper wire has resistance. Equation I can write here. If I say if R3 and RS be the currents in sorry be the resistance be the resistances of primary and secondary coils. Resistance certainly will be there. Some people say there is no resistance in transformer. How can they say the coils of transformer are made of copper wire? How thick it is, but we can decrease resistance by using thick wires, but resistance there. And IP and IS be the currents in the two coils. Then terminal voltage. Then terminal voltage of primary and secondary are Vp equal to Ep minus Ip into Rp. Like cell, I have told you in current electricity, the terminal voltage and EMF are different things. Terminal voltage or Vs ES minus IS into RS. Okay, if Rp and Rs are very small, if Rp and Rs are small, we are assuming होते नहीं, just to understand something easily, then the products Ip into Rp and Is into Rs are negligibly small as compared with Ep and Es respectively. Therefore, we have Vp equal to Ep and Vs equal to Es. I told while teaching cells, the internal resistance like this, external resistance R, small r, current I, E. So E बराबर there और V बराबर I told you कि E minus I into R. Some resistance of cells or battery are taken small, तो तब बराबर होता है. और here Vp, Vs upon Vp is equal to Es upon Ep. Comparing 1 and 2, comparing equation 1 and 2, what you will get? Comparing equation 1 and 2, we get Vs upon Vp is equal to Ns upon Np. Ns and P are the number of turns in secondary and primary coil. So, number 1, if Ns greater than Np, then Vs greater than Vp, and transformer is called step transformer. Transformer is called step up because it will increase the low voltage into high voltage. And number 2, if Ns less than Np, then Vs less than Vp, and transformer is called step down. So these are two types of transformer, step up, step down. Okay. But remember, transformer transforms low voltage into high and high into voltage. It does not generate power. It does not generate power. If you think, okay, there is no problem, by power is equal to V into I, let us increase V, or I equal to V by R हो, तो I बढ़ जाएगा. हाँ, तो by using transformer, ना भी. But if all users are increasing, then what will happen? That is another thing here. So transformer is not a generator. It transforms power, transfers power from primary to secondary coil. And during this transformation, some energy is lost. That is why every transformer has efficiency. So here I am telling efficiency of transformer. efficiency of transformer. No machine work itself. Some power is given to the machine and we get the efficiency of transformer is the ratio of power across secondary coil, which is called output power. Output power to the power across primary coil. This is called input power. That is eta, efficiency eta is equal to output power. Don't leave it as output only. Output power upon input power. Power in circuit P equal to VI. Therefore, I can write here efficiency eta equal to Vs into Is upon Vp into Ip. Like other machines, transformer also have efficiency less than 100. No machine has efficiency more than or equal to 100%. Some energy is lost always by the machine in different form of heat due to different regions. Different machines have different region of power loss. Here there are some regions which cause power loss. I will discuss later on. But we can manufacture the efficiency less than 1 or less than 100%. But we can manufacture transformers having efficiency close to 95%, and such machines are supposed to be ideal. So assuming transformer to be ideal now, eta is equal to 1. Now if ideal, for ideal transformer, which is ideal, which has efficiency close to 100, यानी कि 95% तक ideal मानते हैं. So Vs into Is is equal to Vp into Ip, or here Is upon Ip is equal to Vp upon Vs. In step down transformer, primary coil has primary coil has more voltage. So पहले स्टेप की बात करता हूँ. For step of transformer, Is less than Ip होगा, because here voltage more, primary current more. है भाई. Step 4 step down, Is greater than IP. It does not mean that when you are stepping up voltage, current in your circuit become less. That is less than that primary coil. Because I तो बराबर V by Z है. Z impedance same रहेगा. If you have got voltage output higher than initial one, so current, but that current in circuit here will be less than the current in primary or the current which is generated by source. So I think video has become longer. I will discuss some more points about transformer in next video. Thank you.